In computing, operators are fundamental tools in programming that allow developers to perform operations on data. Operators can be broadly categorized into arithmetic, comparison, and Boolean types, each with distinct purposes and functionality. Understanding how these operators work is essential for creating effective and efficient programs, as they are the building blocks of calculations, decision-making, and logical processes within code. Arithmetic operators are used to perform mathematical calculations on numerical data. These operators allow programmers to carry out basic operations such as addition, subtraction, multiplication, and division, which are represented by the symbols plus, and respectively. For example, in a simple program designed to calculate the total price of items in a shopping cart, the addition operator would sum up the individual prices, while the multiplication operator could determine the cost of purchasing multiple quantities of a single item. Additionally, the modulus operator, represented by %, is used to find the remainder of a division. This is particularly useful in applications such as checking whether a number is even or odd, or distributing tasks evenly across multiple processors. Arithmetic operators can work with both integers and floating-point numbers, allowing for precise calculations involving whole numbers and decimals. Comparison operators, on the other hand, are used to compare two values and determine the relationship between them. These operators evaluate expressions and return a Boolean value true or false based on the comparison. For instance, the equality operator, SC, checks if two values are the same, while the inequality operator, BEG, determines if they are different. Other comparison operators include greater than ish, less than, greater than or equal to, and less than or equal to, ik. These are widely used in decision-making structures such as if statements and loops. For example, in a program that validates user input, the comparison operator could check whether the input falls within an acceptable range, ensuring the program behaves correctly and securely. Boolean operators, which include AND, OR, and NOT, are integral to logical decision-making in programming. These operators work with Boolean values, true or false, and allow the programmer to create complex conditions by combining or negating logical expressions. The AND operator evaluates as true only if all conditions it joins are true. For instance, in a security system, an AND operator might check that both the user's password is correct and their access level is sufficient before granting entry. The OR operator, in contrast, evaluates as true if at least one of the conditions it joins is true. This might be used in an online booking system where either a discount code or a membership status could grant a reduced price. Finally, the NOT operator reverses the Boolean value of an expression. If an expression evaluates as true, applying NOT will make it false, and vice versa. This is useful for excluding specific conditions, such as filtering out invalid entries in a database search. The combination of these operators allows programmers to create intricate and functional code structures. For example, a program designed to recommend movies might use arithmetic operators to calculate a user's average rating of previously watched films, comparison operators to determine whether a new film matches their preferences, and Boolean operators to check whether multiple conditions are satisfied simultaneously. Together, these operators provide the logic and calculations that underpin the program's behavior. Using operators correctly requires not only an understanding of their functionality, but also awareness of how they interact with different data types and contexts. Arithmetic operators, for example, behave differently with integers and floating-point numbers, while Boolean operators can be used to evaluate conditions involving both numerical and textual data. Proper use of these operators ensures that programs are accurate, efficient, and capable of handling a wide range of scenarios. In conclusion, arithmetic operators allow for mathematical calculations, comparison operators evaluate relationships between values, And Boolean operators enable complex logical expressions. These operators form the core of programming techniques, enabling developers to manipulate data, make decisions, and implement logic within their code. Mastery of these concepts is crucial for any programmer aiming to create functional and reliable software.